Hello and welcome back to our session about vectorized or element-wise operations with Numpy arrays. And first of all, let's create an ND array from scratch with the function np.arrange. And np.arrange creates an array with integers, and we can define the beginning and ending points. So here we want to create an ND array from 1 till 11, and it's by convention that the beginning point here, starting point, is including and the ending point is excluding. So this is very similar to the range function which we learned before. So let's create the ND array. And there you can see a name np is not defined. So first of all, we have to import the Numpy package. So by default, the Numpy package is not imported. And before I said that typically we import numpy as mp, but yeah, we do not have to make this abbreviation. So we can also just say we want to import numpy. Yeah, and still not works because we didn't define mp. But what we can do, we can just write out numpy. So the function is numpy.arrange, and then it works. However, the convention is to have an abbreviation. So writing out always numpy is a bit too much work for most of us. So it makes definitely sense to have an abbreviation. So import numpy as np, and then instead of having to write out numpy every time, we can just write np. And there you can see we have a Numpy array from 1 until 10 including. And what we can also do, we can create a Numpy array from 1 till 11 excluding or 10 including, and only every second number is created. So let's see how it works. There you can see starting from 1 we get only every second number till 10. So 1, 3, 5, 7, 9. So 11 is already excluded. Alright, so in this lesson I want to highlight the difference between lists and Numpy arrays when it comes to element-wise operations. And first of all, let's create a list L with 4 elements, 1, 2, 3 and 4. And our intention is to multiply each element by 2. And if we try to just calculate L times 2, then we do not get the result we actually intended. We only get 2 copies of L concatenated. And if we want to make element-wise operations, we have to use a for loop. So we create an empty list, and for element in L, we have to multiply the element and append it to the new list L1. And then we can print L1 with the multiplied elements 2, 4, 6 and 8. And we also know that we cannot make an element-wise addition. So if we want to add to each element in a list 2, then Python drops us an error message. Alright, so let's create a Numpy array from 1 to 4 with 4 elements. With the function np_arrange 1 till 5, 5 excluding, we get an array with 1, 2, 3, 4. And now if we want to make an element-wise operation, so we want to multiply each element by 2, we can do this simply by saying, okay, A, our array, times 2. And this gives us an element-wise operation. So 1 was multiplied by 2, 2 was multiplied by 2, 3 was multiplied by 2, and 4 was multiplied by 2. And we didn't use any for loop or something. It's just so-called vectorized or scalar operation here. And also we can add each element with 2, that's no problem. And we can also square each element to the power of 2. So 1 to the power of 2 gives us 1, 2 to the power of 2 gives us 4, 3 to the power of 2 gives us 9, and 4 to the power of 2 gives us 16. And our vector A, or Numpy array A, can also serve as an exponent. So 2 to the power of A gives us a vector of 4 elements. So 2 to the power of 1 gives 2, 2 to the power of 2 gives 4, 2 to the power of 3 gives 8, and 2 to the power of 4 gives us 16. And we can also take the square root of each element of A. And also we can make an exponentiation with E. So E to the power of A. And we can also calculate the natural logarithm of all elements of A. Moreover, we can also take the sum of all elements, so 1 plus 2 plus 3 plus 4. There's an NDArray method .sum. Yeah, there are actually 3 alternatives to sum up all elements of our array. So we can use the NDArray method .sum. We can use the Numpy function np.sum and then in the brackets a. And also we can use just the sum function, so sum a. This also works with lists, gives also 10. And we can also calculate the number of elements in an NDArray by applying the attribute size. So ape.size gives us 4, and yeah, this is actually the same functionality than the length function, which we already know. And let's create a new NumPy array with the elements -2, -1, -0.5, 0, 1, 2, 3.5, and assign the variable b. And there's also the function np.abs. And what np.abs does, it actually calculates the absolute values of all elements. So you can see here we have negative numbers, and these negative numbers are transformed to positive numbers, to say. So -2 is 2, -1 is 1, -0.5 is 0.5, and so on. Alright, so let's create another array C with the elements -1.7, -1.5, -0.2, and so on. And there's the function np.ceil, and what np.ceil does actually, it element-wise rounds up all elements to the next higher integer. So let's see what we get here. So the next higher integer of -1.7 is -1, and the next higher integer of -1.5 is -1, and so on. And for example here, the next higher integer of 0.2 is 1. And there's also the possibility to have an element-wise rounding down with the function np.floor. So with np.floor, we element-wise round down all elements to the next lower integer. -1.7 gives -2, -0.2 gives -1, 0.2 gives 0, 1.7, for example, gives 1. And we can also round all elements with a given number of decimals. So let's assume here we have a list with -3.23, -0.76, and we can define how many decimals we want to have. And here we can define 1. So we can see here now we rounded -3.23 to -3.2, 1.44 to 1.4, and 2.65 to 2.6, and we can also increase the number of decimals to 2. And I can also say I don't want to have any decimals. And now you can see here, so we have -3, -1, 1, and 3. So np_around has actually the same functionality as the round function, as we already know. Alright, so this is it for the time being. In this session we learned vectorized or element-wise operations with NumPy arrays, and this is quite easy, and we don't need any for loops like with the Python standard library. And in the next lesson we learn about indexing and slicing NumPy arrays. So hope to see you there, and see you in the next session. Bye!